So this week we are going to discuss some very important topics. I will say, okay. So let's start. So this is the snips which we had in our last PDF, where I discussed all the important topics which we will discuss. Okay. So as for the phase one, we are going to HLD. In the HLD, we will be covering the client server APIs, load balancing, caching, databases, CAP theorem, and in the LLD we are covering OOPS, solid principles, design patterns like singleton, factory, strategy, and observer. Okay, but before that we have to learn some concepts. Okay, some important concepts. I will say. So, what do you mean by concepts, and which concepts we have to learn? So, there are some terminologies related to system design. The reason why we are studying here is that we can't go in some other topics and just give the reference. Yeah, as you know. So I want to make sure ki, you are getting aware of all the important terms. I'm not going to cover everything, but yeah, which is used in the industry and which is like most common. I'm going to use that. Okay. So the first term is scalability. ठीक है. So scalability क्या होता है? It's basically ability of a system to handle increased load. Ability of a system to handle increased load. Okay. Now, what we are going, we can see an example like let's say we are having Instagram. Okay, and let's say we're in India and we are looking for the Bangalore region. Okay, so as we know that from 9 to like 6 including that metro travel time, mostly people are busy in their profession, right? But like it might be possible that at 7 p.m. there will be sudden increase in Instagram users. Okay, so what will happen? So basically Instagram will have the scalability in its app or website to handle the increased load. Okay, and for the like upper level career, I'm saying that we are having two types of scaling. One is vertical scaling and another one is horizontal scaling, right? Now vertical scaling, it means we are going to upgrade the machine. Okay, so let's say in the normal time I'm using 4 cores 12 GB CPU. Just for an example I'm taking. Okay, this is for normal time. Now during increase in load, what I will do, I will take 12 cores, 12 GB CPU. Okay, or I will say, or 12 cores, 32 GB CPU. Okay, so basically what I'm doing, I'm upgrading the machine, I'm upgrading the CPU, and upgrading the like overall memory. Okay, so this is called vertical scaling. In vertical scaling, what we generally do, we upgrade the machine, which means bigger CPU or RAM. Okay. Now, what is horizontal scaling? So in this, what we are going, that now it's impossible. Literally, let's say we can't create more than 12 cores and 32 GB CPU, because adding that will be much costlier, much costly. Okay. So instead of this, what we can extra do, we can have more machines. Let's say initially we are having two virtual machines for the like handling of like all the load. Now we can increase it to four virtual machines. Okay, so basically what we are doing, we are adding more machines. So adding more machines comes under the horizontal scaling. Okay, so this is the scalability concept. I think it's clear. Don't worry for the notes, I will give you the notes. Okay, and you can refer this notes as well. I will give you the PDF, and apart from this like class handwritten notes, I will give you the proper structured PDF notes as well, with proper diagrams and everything. Okay, so you don't have to waste your time in making notes. I'm just starting to explain because it will be much easier for you to understand the concepts. Okay, the next topic is we discussed scalability. Scalability. Now I'm going to discuss availability. Okay, so as the name suggests, we are just finding कि क्या क्या machines available है, and कौन कौन सा run कर रहा है. Okay, so it just simply means system is up and running when needed. We can take an example कि like UPI, universal payment interface. It should work 24/7. Okay, so for this we need a machine, we need the system which is up every time. Okay, so this is the concept of availability. The third concept is latency. Okay, so latency is I will just give you an example. Let's say one of my client is in US, and I'm in India. Okay, and let's take another example. One of my client is in I will say Bhutan. Okay, and we are in Bangalore, again India. Okay, so basically it's delivering some packages. Okay, it's delivering some packages. US is delivering some packages to India. It takes 23 minutes. Just taking an example. Okay, it's not in actual data, I'm just taking an example. Now since US is at a distance, at a great at a considerable distance from the India, it's taking 23 minutes to get a data package, or to get a data server, or whatever packets we need. Now Bhutan is neighboring country of India. Okay, so it's only taking 3 minutes. Okay, so in the layman terms, these 23 minutes, these 3 minutes, we can looking at the both situations, from US to India and from Bhutan to Bangalore, we can say that yeah, sending data package from Bhutan to Bangalore is much less, and its performance will be high. Okay, but like it's not a perfect some terms, like it's not a scientific terms or technological term to explain the this timing requirement for the sending of a package or a sending of some data loads or whatever. Okay, and or maybe sending some response. Okay, for the example, like we can take Swiggy is showing the students instantly, otherwise it's taking delay. Like this was the example which we take in normal life. I can take one more example. Let's say I will draw a shape. Okay, give me a second. My shapes are not loading. Okay, yeah. So let's say mm, 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 yeah. So let's say this is Swiggy system. Okay, this is the system of Swiggy. Now what happened? Like there are two person one and person two. Person one के जो interface है उस पे जो restaurants है they're coming too early. Like the moment he opened the app, it gets loaded. Okay, and it takes 23 seconds to get loaded. Okay, now let me like going to structure it. Yeah, sorry, my bad. Not this color. Yeah, yeah, perfect. Now what we are doing for the next like for the person 2, what happened, it took 53 seconds, let's say. Okay, it's for person 1, it's for person 2. So we can definitely say कि performance जो person 2 का है वो थोड़ा slow है, and जो performance person 1 का है it's higher performance. ठीक है. ओके, ये वाला हाई परफॉर्मेंस है. सो वी आर गेटिंग कि ये एक इम्पॉर्टेंट टर्म है for the terms of system design. Okay, so latency is in layman language time taken to get the response. Okay, so I will just simply write latency means time taken to get the response. Okay, इसको example I will take Swiggy restaurants instantly versus delayed. Okay, so these three terms we discussed. There are more terms like throughput, fault tolerance, consistency, partition tolerance, replication, for partitioning, CDN, and yeah. So we will discuss these terms in the next video. For now, let's revise the concept of scalability. It means availability of a system to handle the increased load. We took an example of Instagram, like peak time and non-peak time wala. Then we discussed vertical scaling and horizontal scaling. Then we discussed availability. It's so simple. We discussed the example of UPI. Then in the latency we took real-time examples, like one is the from US to India and from Bhutan to Bangalore. So yeah, this is like more high performance. So we will consider this like for real-time application, and we will ignore this. Okay, we will find some way to decrease this latency time. Okay, and then we took an example of Swiggy for the person 1 and person 2, and then we discussed like it's taking 23 seconds for this person and 53 seconds to get all the informations for the person 2. So yeah, in overall terms P1 is system is like more compatible and more high performance. And then we discussed the latency with an example like for the real scientific terms. Okay, so that's all. In the next video we are going to discuss the other terms which I mentioned earlier. So yeah, thanks all. Bye bye.